Lecture number 6. So let us have a recap of what we have studied in the last class. We studied about the fundamentals of measurement theory. In the last class, we saw the definition, the operational definition, and the measurement. We also saw that it is undisputed that measurement is crucial to the progress of all sciences, isn't it? So this is the professional view, what we are proceeding. So the thing is, we should every whatever software we are being it is being developed, we are measuring it. So this measurement is a crucial thing, which is which provide a basis for progress. We have also seen in the last class the front end and the back end of the software development. The design, the coding, the debugging and integration phases are classified as the front end of the development process, whereas the machine testing and early customer trials, they constitute the back end. So when we talk about the quality of the software, we have to focus on the front end as well as the back end, how we are going to improve the quality of the software. In the last class, we also saw that another indicator for good reviews and inspection could be the scoring of each inspection by the inspectors at the end of inspection. Based on the set of criteria, we may want to operationally use a 5-point Likert scale. So this is important scale. This is we call it as a Likert scale to denote the degree of effectiveness. Means how we are going to measure. We have got a scale in which we are setting different numbers. Means there are different scales like 5, 4, 3, 2, 1. 5 denoting very effective, 4 denoting effective, 3 somewhat effective, 2 not effective, and 1 is very poor inspection. This all we studied in the last class. There is some scale. From this scale, we are going to measure the quality of the software. It may be depending, we can get the survey or reviews from the customer. So today in this class, we are going to learn three different scales. One is nominal scale, ordinal scale, and interval and ratio scale. So let us start with the level of measurement. When we operationalize a definition and derive measurement indicators, we must consider the scale of measurement. This is what we have learned from the previous classes, isn't it? So we have got the measurement indicators. There is a measurement scale from which we are knowing the quality of the software. This scale, from this scale, we can know what level the software is. So we have seen from the theory to empirical hypothesis, isn't it? In the last class, we saw there are three hypothetical ideas, isn't it? And there is a empirical data. Empirical data is nothing but practically processed data. Means at the first level we have got the hypothesis, at the second level we have got the empirical data. We have seen that from theory to empirical hypothesis and from the theoretically defined concepts to operational definition, the process is by no means direct, isn't it? As the example illustrates, when we operationalize a definition and derive measurement indicator, we must consider the scale of measurement, isn't it? So we must consider there should be a scale of measurement. There should be a scale of measurement. For instance, the measure of quality software inspection, we may use a 5-point scale, isn't it? 5-point scale, Likert scale, isn't it? To score the inspection of effectiveness, or we may use percentage to indicate the inspection coverage. For some cases, more than one measurement scale is applicable. For others, the nature of concept and resultant operational definition can be measured only with a certain scale. For different parameters, for different aspects, we can have different parameters that can be assessed on a different scales. So when we talk about the nominal scale, isn't it? When we talk about the nominal scale, the most simple operation in science and lowest level of measurement is classification. The most simple operation in science and the lowest level of measurement is classification. Just to understand the concept, see, if the attribute of interest is religion, isn't it? We want to measure it. We can classify the subject into, see, religion Islam, religion Christianity, religion Hinduism, isn't it? So that is the first step. The most simple operation in science and the lowest level of measurement is classification. Whatever parameter is there, we are going to classify it. This religion has been classified into three different sectors, isn't it? So same thing we can apply for the software. When we talk about the software, if we classify software products by the development process models through which the products were developed, then we may have different categories. We may have different categories. The categories may be object-oriented programming process, waterfall development process, spiral development process, iterative development process, etc. There may be so many, but I have just enlisted only four, isn't it? So when we are going to classify this software product, then we have to tell that what model we have used to develop the whole software, isn't it? So it can be classified into different models. The model may be OOP model, waterfall model, spiral model, or iterative development model. So this is a way how we are going to classify the product. In a nominal scale, the two key requirements for the category are jointly exhaustive and mutually exclusive. I have marked in the green and yellow so that they are important terms. In a nominal scale, the two key requirements for the categories are jointly exhaustive and mutually exclusive. These are the two requirements, they are fulfilled in the nominal scale. Mutually exclusive means a subject that can be classified into one and only one category, isn't it? Mutually exclusive means a subject can be classified into one and only one category. If you have studied the probability, you might be knowing what is a mutual exclusive event. A mutual exclusive event is one when you toss a coin, either it will be a head or either it will be a tail. There is no chance that at one point, at one instant, it is a head and tail, isn't it? That is nothing but mutually exclusive. Mutually exclusive means a subject that can be classified into one and only one category. Jointly exhaustive means that all categories together should cover all possible categories of the attribute. Jointly exhaustive means that all categories should cover all possible categories of the attribute. If the attribute has more categories than we are interested in, and another category is needed to make the categories jointly exhaustive. So this is all about the nominal ordinal scale. This is all about the first one, that nominal scale. After the nominal scale, we are going to study this ordinal scale. What is ordinal scale? Ordinal scale refers to the measurement operations through which the subject can be compared in order, isn't it? So in nominal scale, what we did, we have classified, isn't it? In the ordinal, what we are doing, we are going for comparison. For example, we may classify families according to socio-economic status, isn't it? As in the classification we told different religions, here we are classifying in similar example we are taking. We can classify the families according to socio-economic status. One we can call it the upper class, middle class, and the lower class. Means three different classes are there with in accordance with the status of the family. We may classify software development projects according to SEI, means Software Engineering Institute. The maturity levels are according to a process rigor scale, isn't it? So how we are going to classify this software product? We are going to classify the software product according to SEI maturity levels or according to a process rigor scale. Totally adheres to a process, somewhat adheres to process, that does not adhere to process, isn't it? So we have got some rigor scale, we have got some standard in which we are testing that whether it is a totally adhere to process, or second condition whether it somewhat adheres to the process, and the third is it is not going to adhere to the process. I mean, three conditions we are checking. Our earlier example of inspection and effectiveness scoring is an ordinal scale. See here, a few more things in the ordinal scale are: an ordinal scale is asymmetric. What does it mean? If A is greater than B is true, then B is greater than A is false. It is very much obvious now. If A is greater than B, already A is greater than B, obviously, then B is greater than E, it cannot be true. Obviously, it is a false only. This is a symmetric property of the ordinal scale. The second property is it has the transitivity property, in that if A is greater than B and B is greater than C, then A is greater than C. The transitivity property, what it tells, that if A is greater than B and B is greater than C, isn't it? A is greater than B and B is greater than B is greater than C, obviously, eh, then obviously A is greater than C. These are the two properties in the ordinal scale. One is a symmetric property, another is the transitivity property. So, however, we cannot say that the difference between the former pairs of the categories is the same as that between the later pair. In customer satisfaction surveys of software product, the 5-point Likert scale is often used with, we have a convention, 1 is equal to completely dissatisfied, 2 is equal to somewhat dissatisfied, 3 is a neutral or okay, 4 is satisfied, and 5 is completely satisfied. So we know that only 5 is greater than 4, 4 is greater than 3, and 5 is obviously greater than 2, and so forth. But we cannot say that how much greater 5 is than 4. See, this is very important technical thing. Anyhow, we are going to measure, but our measurement is based on some comparison, isn't it? We are not exactly telling how much it is. So I have marked this sentence in a yellow so that it is a very important thing. We can tell that 5 is greater than 4, but we cannot say how much it is greater than the 5 is greater than the 4. Nor can we say that the difference between categories 5 and 4 is equal to that between categories 3 and 2. Indeed, to move customers from satisfied 4 to very satisfied versus from dissatisfied 2 to neutral may require very different actions and types of improvements. When we talk about some practical scenario, we want that the quality of the product should be improved. Means what we have to do means from 4 to 5 we have to reach, isn't it? And from 2 to 3 we have to reach, isn't it, from in this scale. So they may require different actions and different strategies to improve the product of the software. So the main thing is, we can compare the two levels, but exactly we cannot tell that how much this is greater than that. So we cannot use operations such as addition, subtraction, multiplication, and division, isn't it? So what we can use? We can just use greater than or less than. So in this ordinal scale, what is possible? It is possible that we can compare two parameters, isn't it? So that comparison operators, what we can use is greater than or less than. We cannot use the other operators such as addition, subtraction, multiplication, and division. So we have learned the nominal scale, ordinal scale, and the third is interval and ratio scales. An interval scale indicates the exact differences between measurement points, isn't it? We are coming to one important point, that is, what is the exact difference between measurement points. The mathematical operations of addition and subtraction can be applied to interval scale data. For instance, assuming products A, B, C, these are the three software products, and these three software products are developed in the same language, isn't it? Just for our convenience, we are telling that the platform is same and the language is same. They have been developed. If the defect rate of software product A, the defect rate of software product A is A per kilo per KLOC, line of code. If the product defect rate of A is 5, the defect rate of B is 3.5, the defect rate of C is 2, isn't it? You have got three different softwares and we are measuring the defect rate, isn't it? So how we are measuring? How much time the we are measuring with the KLOC, defect at so and so line of code, 1000 line of code, how many defects are present. So an interval scale of measurement requires a well-defined unit of measurement that can be agreed on as common standard and that is repeatable. Given a unit of measurement, it is possible to say that the difference between two scores is 15 units, or that one difference is the same as second, isn't it? So what it tells, assuming the product C's defect rate is 2 defects per KLOC, we can thus say that the difference in the defect rate between products A and B is the same as that of B and C. See, in the earlier cases, we saw that we can compare. We don't have exact numbers, but when we come to the interval and ratio scales, we are getting some exact numbers, isn't it? That from these exact numbers, we can tell that which software is better than that other softwares. So in the interval and ratio scales, we can have different ratios because we are taking how many defects per kilo per k, means 1000 line of code. Depending upon that value, we are going to measure the different software products. So here we are exactly getting the differences between different softwares. So one more important thing when we talk about measurement scales and hierarchical, so measurement scales are hierarchical. What does it mean? Each higher level scale possesses all properties of the lower ones. The higher the level of measurement, the more powerful analysis can be applied to the data. Therefore, in our operationalization process, we should devise metrics that can take advantage of the highest level of measurement allowed by the nature of the concept and its definition. A higher level measurement can always be reduced to a lower one, but not vice versa. A lower one cannot take up the higher level, isn't it? So a higher level measurement can always be reduced to the lower one, but vice versa is not possible. For example, in our defect measurement, we can always make various types of comparisons if the scale is in terms of actual defect rate. If actual defect rate is there, we can have different types of comparison between different softwares. However, if the scale is in terms of excellent, good, average, worse, then average and poor as compared to an industrial standard, then our ability to perform additional analysis of the data is limited. Obviously, what we have seen in the ordinal and nominal, we don't have the exact number. We are scaling them as a excellent, good, average. So when we talk about this good, excellent, we don't have exact number. So whatever analysis if you want to do, they are all limited, isn't it? So anyhow, we are going to measure the quality of the software.